In this presentation, we will build skills you will use to complete this week's lab. Bathymetric contours basically tell us how deep things are beneath the surface. For example, this boat is sailing over the sea. Underneath it are two pyramids, but how deep are they? Well, you could dive down 10 feet and hit the peak of each. Each one has a peak 10 feet below the surface. That means I could probably swim further down and hit a place on it that was 20 feet. Boom. Every point on the red lines is 20 feet below the surface. Now let's add the rest of the contours. 20 feet, 30 feet, 40 feet. If the water were very clear, and if I had painted these lines with red paint, the boat could sail over them, look down through the water, and over the big pyramid it would see this shape. Well, people on the boat would see. And this is a smaller one representing the steep, skinny pyramid here. It would look like this. These lines are called contours, and we're going to talk about them today. Bathymetry, you might remember from the other slideshow, is the measurement of depth. Bathy means depth. Metry means to measure. Contours, those red painted lines, they represent equal depth. And the funny thing about these lines is they're not allowed to cross each other. They have to be regularly laid out. So I know that every single one is 10 feet deeper. You can't go 10, 10, 10, 30, for example. If they are close together, then it is a steeper slope. Remember that the skinny pyramid had these lines that were very close together. And then there's something called the rule of V's. And I am including an additional video in this module that talks about the rule of V's. Suppose I ask you to construct a profile along line XY. A profile, a synonym for this is cross-section, is a sideways view. What I'm going to do is make a little dot on line XY everywhere it crosses a contour. Here it crosses the 40-foot contour, then the 30-foot, then the 20-foot, then the 10, and so on. And if I bring those dots straight down onto this little graph provided here, I get this shape. We can do it for the other one too. Don't forget to connect the dots. Now we have two accurate sideways representations of the sea floor. Sometimes a map has depth measurements, but no contours. It's easy to draw your own contours in. Let's say the interval here is 10 feet. Each contour line will represent an increase of depth by 10 feet. Well, there's a 10 here. Let's see, I'm going to draw a contour line there. The next one will be 20. Well, 20 is bigger than 14, but smaller than 22. What will this look like? Here we are. The 10-foot contour does not end. It goes all the way to the edge of the map. The 20-foot contour, a little more interesting, separates numbers that are smaller than 20 from numbers that are bigger than 20. The 30-foot contour, on one side of it, numbers are bigger than 30. On the other side, they are smaller than 30. And since we have a round 30 right here, we're allowed to go right through that because that's equal to what is represented by this contour. Now let's talk about scale. This map shows a little island. The map is smaller than the real island, but by how much? The scale tells you. The real island is 10,000 times bigger than this map. Notice that this ratio has no units. It doesn't say 1 island equals 10,000 islands, or 1 meter equals 10,000 meters, or 1 pound equals 10,000 pounds. That's because it is one size fits all, and I am going to show you how to use it. Let's say 1 inch on the map has been drawn, and I want to know what that means in the real world. If I went here in the real world, I would cross 10,000 inches. So you could say 1 inch equals 10,000 inches. You could also say 1 foot equals 10,000 feet. It's apples to apples. As long as you use the same thing on both sides, you're okay. Now let's practice this. I forgot the letter L. I just saw this should say, how many feet in the real world do 3 inches on the map represent? Let's think about it. I'm not going to worry about feet yet, but 3 inches on the map, 3 inches on the map, well, if 1 inch on the map equals 10,000 inches in the real world, 3 inches on the map equal 30,000 inches in the real world. Now here I've provided you with some conversion factors. I will always provide these, or you can look them up, or you can look in the very back of your online free lab manual, link provided in syllabus. 3 inches on the map equal 30,000 inches in real life. And the question wants me to turn that into feet. There are 12 inches in a foot, so here's my setup. 30,000 inches times 1 foot divided by 12 inches will cancel out the inches. I will get a number followed by a foot. You can practice that one if you like and talk to me about your answer. Now go for it. You have another video about the rule of ease, and you are now ready to start this week's labs. Hit me up with your questions, you guys. I do private Zoom lessons for groups or for individuals. I do teleconferences, and I love to answer questions over email. Don't be shy, reach out, and have fun.